Hi guys, today we're talking about section 2 in chapter 2, looking specifically at the properties of water. Now you guys know a little bit about water. You know that it is a molecule made of 2 hydrogen and 1 oxygen. But what you may not remember is that it's considered a polar molecule. Why? Well, because the oxygen attracts more of the electrons and becomes slightly negative. The hydrogens then become slightly positive. So the molecule itself, as you see in this picture, has a slightly negative side where the oxygen is and a slightly positive side where the hydrogen are. And that makes it what we call a polar molecule, kind of like the poles on a magnet or the poles on a battery, positive and negative. That molecule has that type of charge. It's because of the uneven distribution of electrons. Now that has some important ramifications. The positive hydrogen will attract the negative oxygen of a nearby water molecule. And that attraction is held together by what we call hydrogen bonds. And one water molecule can bind to 4 other water molecules this way. So it's a pretty interesting and special type of bond because it gives water some certain properties that we'll look at in just a minute. These hydrogen bonds account for many of water's special properties, such as cohesion. Cohesion is the attraction of water, the definition of cohesion is the attraction of molecules to the same substance, so molecules of something that are attracted to each other. So in this case, we have water attracted to water, and it's because of those hydrogen bonds that they hold together. Now, this is important because it gives water some special abilities, and one of those is something we call surface tension. Surface tension is when the water surface kind of creates a membrane because of those hydrogen bonds, and that allows certain insects, spiders, maybe even Jesus lizards to go across the surface of the water without breaking the membrane. And that is due to cohesion. Now, another property of water is adhesion. Adhesion is the desire of water to hold on to other materials like glass or tree trunks or lots of things. And it's called adhesion. And one of the ways we see adhesion, and one of the ways it's really important, is with capillary action. So let's look at the next slide here. How do trees and plants get water? Well, they don't get it when it rains on their leaves. They all get all their water from the ground. Water moves up through the roots and then is pulled up through the stems out to the leaves. And this happens with the smallest of plants to the largest of trees. So you actually, in effect, have water moving against gravity. And this is only possible because of what we call capillary action, which is 2 things happening. It's the tree pulling on and adhesing to the water, and then the water is adhesing to other water molecules and pulling them up as well. So you get this continual pull of water up through the tree trunk, out the stems, and into the leaves of the tree. So high heat capacity is another very important property of water. High heat capacity is the amount of heat required to increase the temperature. And for water, that's relatively high. It actually takes quite a bit of energy to increase the temperature of water. That's a great thing because it keeps ponds and lakes and the ocean at pretty stable temperatures so that creatures are able to survive in there without the water getting too hot or too cold. So having a relatively high heat capacity is a really important property of water. All right, now let's move off of water and talk about something else for a moment. Mixtures. Mixtures are when you put 2 or more elements or compounds together. You physically mix them, like stirring them. You can think about that. They're not chemically combined. So, for example, you have some jelly beans here, and this is a mixture of jelly beans. And what makes it a mixture is that it can be physically separated back out into its different parts. So you can think about like Fruit Loops or Raisin Bran or chocolate chip cookie dough. It's a mixture because it has different parts in it, and you can see the different parts, and they can be separated. Now here are some special types of mixtures. One of them is called a solution. A solution is where when you mix in the components, they mix up so well together that you can't see them. You can't see them separate. So those are things like Kool-Aid and chocolate milk and tea. And when you do mix things together, there's actually two parts to the mixture. There's the solute and the solvent. Well, the solvent is the substance in which you're putting the other substance. So, for example, if you're making lemonade, you have water, that's your solvent. What do you add to the solvent, to the water? You add the lemonade and the sugar, and those are the solutes, and you stir them in. So they're the things that are dissolved. So the solute is the substance that is dissolved. So for example, chocolate milk, the syrup is the solute that you put into the milk, which is the solvent. And water is known as the universal solvent because it can dissolve so many things. Now another type of mixture is called a suspension. This is when you put the materials together and they don't dissolve, but they do separate out into pieces so small that they don't settle out. So you can shake it up and they stay mixed up. They are suspended, if you want to think of it that way, in the solution. And so you can see them. They don't settle to the bottom. That's a special kind of mixture called a suspension. All right, lastly in this section we want to talk about acids and bases and buffers. So liquids and substances have they range from 0 to 14 on what we call the pH scale. They have different pHs. And pHs, technically, it's really a measure of the concentration of hydrogen ions in a solution. The more hydrogen ions, the more acidic something is. The less hydrogen ions and the more OH ions, the more basic something is. Pure water has a 7 on the pH scale. Everything below that is an acid. Everything above that is a base. So acids, when you have an acid, they form hydrogen ions in solution. The more hydrogen ions, the more acidic they are. So 1 is the most acidic and 7 is neutral. Bases are compounds that make OH ions when they are put into solution, and the strongest bases have a pH of 14. And then buffers are weak acids or bases that can be put with strong acids and bases to try to bring them closer to 7, bring them back to neutral. Buffers are really important at keeping things from getting too high or too low a pH. All right, that's all we have today. Make sure you read your book.